Hello everyone, welcome back. This is part 3 of Technician Prep. Okay, going to do some rules this time, a little boring, I know, to some degree, so I won't do too many. I'll try to mix it up a little between doing rules and operating procedures, things like that, and theory, so that'll make it a little more bearable. Now, a lot of the rules are just memorization, it's just the way it is, and some of them are answers that are always going to be the same no matter how you word the question and no matter how you word the multiple choice answers. It's always going to be the same answer if it has the same similar words in it, always. One of those type of things. So anyway, let's just start. I'll explain those as we go when we hit them. Which of the following is the purpose of the amateur radio service as stated in the FCC rules and regulations? Now, this one has some things that is important to discuss, and one of which is that it will never have to do with business or money, ever. It's one of the few things left in the world that is that way, really, if you ask me. So it's not providing personal radio communications for as many citizens as possible. No, it's not. There are services that do that, but the amateur radio service is not defined as one of those. And it has nothing to do with just international nonprofit, which is what B says. And again, they're trying to catch you there because it says nonprofit, but it's not it. Anyway, C is the answer, and C is always going to have, or C, the answer is always going to have advancement of radio skills, technical skills, communications, and radio art. Those words, those concepts are always going to be in the answer. So if you see any answer that has all of those in it, or most of those in it, it's probably the answer. And also, by the way, for ham radio, again, it is non-business. However, there is an exception to ham radio operators as far as selling their own equipment on the air if they want, as long as it's not part of a business. If they're just doing it yourself, private sales, and between individuals, that's fine. Okay, so which agency regulates and enforces? I'm up here. Regulates and enforces the rules. It's the FCC. Always will be. No other answer is acceptable. And I'm sure most of you guys know that. Hams and CB operators alike know that answer. Next question, which part of the FCC regulations contains the rules governing amateur radio, which would be part 97, always. Part 95, I think, is the one that governs CB radio, if I'm not mistaken. I don't remember the rest of them. No reason to know them, no reason to confuse everything with that, so I'm not going to. Next question is, which of the following meets the FCC definition of harmful interference? There's harmful, there's willful interference, malicious interference. But for this question with harmful interference, it's that which seriously degrades, obstructs, or repeatedly interrupts the radio communication service operating in accordance with the radio regulations. I'm guessing that this is somewhat out of the world of willful and malicious interference, and maybe it's sort of the catch-all for everything else, like electric blankets because they get noisy, or heat tapes, or touch lamps, whatever, that type of thing. If I'm wrong on that, by the way, please make a comment. Some of these questions are a little iffy, I believe, sometimes. I could sit here all day and not get an email, and then start a video and get 5. Next question, what is part 97 definition of telemetry? I have a story on that because it's an example. The answer that they give is a one-way transmission. It's important that it's one-way transmission of measurements, and that part's probably important too, at a distance from the measuring instrument. I can't speak English. Measuring instrument. A while back, NASA put up 2 satellites in orbit. They were called Castor and Pollux. They were part of an Andes experiment. And many amateur radio operators around the world receive telemetry from those satellites. The experiment was to um, see the effects of different things like solar wind, um, geomagnetic type activities, just whatever drag on the orbit decay of the satellites. The satellites are actually like perfect spheres, so there was nothing to cause any drag at all other than stuff that would happen in space, and they were trying to collect data on that. So the satellite continually transmitted its own health status as far as batteries and stuff like that, its operating parameters, and make sure it's healthy. That's was part of telemetry that was sent down. The information that is sent was part of that telemetry. And then the other part of the telemetry was, I believe, orbital decay type information. So because that's what the experiment was about. Anyway, that's what telemetry was, and in that case, and that's what telemetry is. Next question. Which of the following entities records, transmits, receives signals, or channels rather, and other parameters for auxiliary and repeater stations? Recommends. Okay, that's the frequency coordinator. I mean, enough said. It's determined locally by the people in the area that have repeaters. It's important to have somebody to coordinate frequencies because repeaters can cover quite an area, and you don't want overlapping frequencies because there would be unintentional and harmful interference, I might add, which is one of the other questions, right? We just did. What is the FCC Part 97 definition of an amateur radio station? And it is a station in the amateur radio service consisting of the apparatus necessary for carrying on radio communications. It's always kind of worded that way, so I guess just basically memorize the wording of that answer, and anything similar to that's going to be right. It's always been kind of worded that way. By the way, there are some questions in regards to rules and things that, if I didn't already say it, that the answer is always going to be that answer regardless of how they word it, because it just is. We'll see. Like this is actually a good example. When is willful interference to other amateur radio stations permitted? Okay, and the answer is at no time. There's no exception. It's never, don't do it. Unfortunately, there are people out there that are doing it, but they're getting caught and they're getting fined for doing it too. So, in fact, I just read one recently. A guy was hit with a $15,000 fine. So, folks, don't do it. Next question, which of the following is a permissible use of the amateur radio service? Broadcasting music is never, ever acceptable or permissible, ever. Okay, that's one of those kind of questions. And then the next answer, or they have, is providing a way for amateur radio operators to earn extra or additional income for using their stations. Never, ever is that the case either. Okay, it's the non-profit type of thing. Do not use it for business. The next one that rules that out, because that says for startup businesses, so that one's definitely not it. So the answer is D. Allowing a person to conduct radio experiments. I'm not sure why they say radio experiments, other than maybe advancing the radio arts and communication skills, so they consider that radio experiments. And to communicate with other licensed hams around the world. Woo! That's what it's all about. Yeah, baby. Okay. What is the FCC Part 97 definition of telecommand? This is more of a memory than not. A one-way transmission to initiate, modify, or terminate functions of a device at a distance, like a remote operation of a repeater, perhaps. I was also thinking earlier that that might fit into what Echolink does, because you can initiate an Echolink connection from your car, and we can get into that some other time. I could do a whole video on Echolink. It's a lot of fun. It's interesting. But that would be another example of that, because you have to punch certain tones in on your keypad on your microphone, and then it brings up the Echolink on the repeater, and then you can actually connect to a node anywhere in the world that way and talk from your car to anywhere in the world that has a repeater that supports Echolink. It's very, very interesting. It's a lot of fun, actually. What is the ITU? That's the International Telecommunications Union, and it is a United Nations agency, that's important that that's in the answer, for information and communication technology issues. They do a lot of international frequency coordination. um, so that's enough of that. I don't think you really get a whole lot with the ITU on your test anyway. All right, this is a little more techie question here. Woohoo, right? Um, so which frequency is in the 6-meter band? So a little chatter about this, okay? So when they say 6 meters, that's actually the wavelength length, actually, of one wavelength in 6 meters long. That's what they're saying there. Um, and something else to remember is that as you go up in frequency, the wavelength becomes shorter. Okay, so like say on 14 megahertz, it's 20 meters, and then on um, around 50 megahertz, it's 6 meters, which is shorter. So that's important. And the analogy to that, if you need a way to remember it, I put down here is just that it's like if you have bigger objects, I put down a gong because the gong's like long, really low frequency, you know, when you hit it. Or it may be like chimes, you know, you have the longer chimes make a lower frequency and the shorter chimes make a higher frequency because they're shorter. It's the wavelength shorter, the resonant frequency is shorter, okay? Or well, the resonant frequency is higher. Okay, so a way you can remember that and calculate that fairly quickly without too much memory is if you want to know what band it is in meters, now it's important when you do this formula that the frequency is the way I've got it, and for the test it'll be adequate. The frequency in megahertz and the number 300, okay, so you're dividing 300 by the frequency in megahertz will give you whatever band it is that they're saying it is in meters. So the example, they've got 52.525, which is 5.711 meters, which is actually in the 6 meter, what we call the 6 meter band. I mean, the only thing that's going to equate to exactly 6 meters is 50 megahertz, because 50 into 300 is 6. Okay, so as you go up in frequency from 50, that number is going to get smaller, right? Because as you go up in frequency, the wavelength becomes shorter. So that's why this is smaller than 6. Okay, now the one answer they give is 49 megahertz. And 49 megahertz comes out to 6.122 meters. And you would go, well, look, 6 meters. No, actually, it's greater than 6 meters because it's 6 point something. Okay, so it's above that frequency. So, and part of this, guys, really is you should know your frequencies. At least, if nothing else, know the range of the frequencies within reason as far as passing the test and doing the questions and everything. And so this one seems a little tricky, 49, but the 6 meter band starts at 50. So it's automatically not in there, but it's just really close. Okay, and this is definitely it, B. And then C is obviously not. And these are, I mean, the other two are way off. So, but I have seen questions where they ask you exactly what the frequency range is. So, you know, beware. Okay. And as far as the bands and meters and stuff, if you can remember this right here, 6 meters is 50 megahertz, 2 meters is 144, 1.25 is 220, 70 centimeters 440, and 23 centimeters is 1296 megahertz. That's going to probably get you through most of the questions when they ask you what band it is and what frequency, either way you go. And by the way, if you work this formula up here, it's always 300 over whatever. So if you've got to reverse that and get the frequency, then it's 300 over the band in meters. So if you work this backwards, and they said, well, what frequency, or, yeah, what frequency, no, okay, my brain's not working here. Yeah, so what frequency is, you know, 20 meters? Well, you divide 300 by 20 and get the approximate frequency, and then you just have to look on your answers and see which one fits it the closest. I don't think I've only seen a couple of those, so I wouldn't worry too much. Okay, I only got a few more questions here, so the timing's coming out good. Why should you not set your transmit frequency to exactly at the edge of the amateur band or subband? Because, this is all these answers, but Let's just go through them and explain why they are what they say. So to allow for calibration error in the transmitter frequency display, right, because no transmitters, they can be close in New Orleans or really close actually, but if they are off, you would be out of the band. 1. 2, so that modulation sidebands do not extend beyond the band edge. So if you're on lower sideband on some frequency, let's say like your band edge is 3.8 megahertz and you're right on the edge, and you're on lower sideband, that means your lower sideband, well, it means your carrier is at 3.8 megahertz, but your sideband is going to be lower than that, so it's going to be out of the band. So you have to watch that. And that's what it says. So the modulation sidebands do not extend beyond the band edge. And then C, it says to allow for transmitter frequency drift, of course. I mean, again, if you set it and you're right there and then you drift 20 hertz to the out of the band edge, you're still out of the band. So, I mean, one cycle out of the band is out of the band. Now somebody go sit there and go, I saw that, I measured you with my equipment, and you, no, probably not. But the idea is it's good amateur radio practice, operating practice, and that's what you should do. Okay. Why should you not set your transmit frequency to be exactly at the edge? We did that. I guess I moved that, sorry. Which of the bands above 30 megahertz that are available to technician class operators have mode restricted subbands, which is C, 6 meters, 2 meters, and 1.25 meters. And I believe the mode restricted, oh actually, I have another, if I can move this window up and show you, there's one more question, and that is that question. Let's see if we can move this up so you can see it. There we go. What emission modes are permitted in the mode restricted subbands at 50 to 50.1 and 144 to 144.1? And the answer is CW only, which is Morse code, by the way. And that's the only thing you can use in those areas of those bands. So it's mode restricted subbands. And also on the note on bands, while we're going here, there's several band plan charts out there that you can download. There's one on the ARRL. There's one on the CQ amateur radio site. There's several out there, and it shows it's all broken down by frequencies and which class license can operate which frequencies and which modes, meaning CW or teletype or sideband or AM or FM, what have you. Really good to keep one of those around, laminate it, stick it in the shack. So, all right. Hope everybody's still awake. The next one I'll try to do a little bit of theory instead, and like I said, mix it up a little. So thanks for watching, and again, if you like, please share and like and subscribe and all that fun stuff. It's always appreciated. It helps the channel, keeps me going. You guys are great. Thanks again for all the comments too. 7-3 for now.